So this question emphasizes that about the weight. It says what weight of sodium hydroxide, that is NaOH, is required to make 500 centimeter cube of 0.2 molar concentration. So you can note that we are looking for the mass, not the molar mass. We are just looking for the mass that is formed based on this reaction, based on the concentration and the volume that was given. So we are looking for the mass, what weight. So we have many formulas that could relate to the answer. So we'll take them one by one. Now the weight is relating to the mass in grams. So therefore, we have many formulas. They correlate to one another. So we use them. So the first one is N. The number of moles is equals to the mass in gram over the molar mass over the normal mass relating to the standard mass. For example, aluminium, I think the standard is, sodium, the standard is 23. So then if you take the formulas, N equals to the mass, the reacting mass, that's what we call it. The reacting mass is M over the molar mass, M. So we can take it like N equals to M over small m over big M. If you just know that part, you know the rest, because you can use simultaneous, you can use some surrogate of the formula to get the rest. So big M will now be small m over N, that is small m over number of moles, that is reacting mass over number of moles. Then the small m, which is the reacting mass, equals to number of moles times molar mass. So that is it. So don't forget that you can use the concentration and the volume, either of acid and base, to get the number of moles that is being reacted here. So we still need that formula also. So now we have gotten the formula. So in order to get mass, we can use the N equals to small m over big M. The N is the number of moles. The small m is the reacting mass. The big M, which is the standard has to be in capital letter. The standard M, which is the big M, is the normal molar mass. For example, sodium is 23, oxygen is 16, hydrogen is 1. So you can see that whether the molar mass, if it's an element single, or the relative molecular mass, once you relate it to compound, you just calculate everything standard based on 1 mole. So now we look at that. So we have N equals to mass in gram over M. That is the third line. Then you see the arrow, meaning we are looking for the M. The reacting mass is the small m. The standard is the big M. The standard has to be in capital letter. The standard has to be in capital letter. It can be standard atomic mass or standard molecular mass of all the elements that make up the compound. So the M is what we are looking for. But at the same time, if you look at those arrows, we need to find the N and we need to find the standard M. So to find the N now, the N, we were given the concentration and the volume, but the volume has to be in dm cube. So divided by 1000. So 0.2 times 500 over 1000, blah, blah. You see the solvents, the number of, but this one is relating to base. Sodium hydroxide is a base, so it's 0.1. Then what about the rest? To get the M, which is the relative molecular mass now, not the relative atomic mass, to get the standard mass of what? We are looking for the standard mass, not of an element. The standard mass of an element is the atomic mass, but the standard mass of a compound is the relative molecular mass. So sodium, oxygen, and hydrogen make up sodium hydroxide. So some people don't know that. So 16 is for oxygen, 1 is for hydrogen, 23 is for sodium, and each of them is single. So we don't need to multiply. But assuming it's NaOH and you see something like 2, something like that in one part, so you relate them according to the multiplication. So we move on. So once you calculate the standard, is 49 that we've gotten that. Now the formula again, therefore the formula is N equals to small m over big M, mass, reacting mass over the standard mass, whether relative atomic mass or relative molecular mass. So you plug in the value, solve. That will be the final answer.